Everyone, happy Tuesday to each of you. I'm not actually recording this on Tuesday, but I'm assuming that's when you're listening to it. First off, I honestly miss you all very, very much. I wish that I could tell you in person how grateful I was to get the chance to teach in person for the month and a half that I did, but I am sure that we can absolutely make through this new set of challenges to the best of our ability. All right, guys, this is designed to follow along with the notes that are printed. And what you see under this week's focus is the same general outcomes that are on the email that you would have gotten as well. So this is going to be our focus for this week. This particular podcast today, I'm going to focus on describing the properties of gases, in particular volume, pressure, and temperature. Now, if you have a look similar to what we used to do in class, that what is underlined and bolded is what you need to fill in. So when you check out properties of gases, notice that they're numbered. That's going to come in handy for you when you end up going to your worksheet. So we end up with a relationship here that's actually called an inverse relationship. That volume of a gas goes down when pressure is exerted. So think about what those two things mean. If volume of a gas goes down when pressure increases, right? That's why it's an inverse type relationship. Vice versa, if you keep on going, gases expand, that's related to volume, folks, as temperatures increase. So those two are a direct relationship. So volume goes up as temperature goes up. And there's a little picture there to show you what's happening. The one on the left, if you can imagine right here, we have that situation when pressure is low, volume is high, and then over here, when pressure is high, the volume definitely goes quite a bit lower. Remember, guys, you can pause this presentation anytime. So if you feel like I'm going too fast for you to write something down, pause. No big deal. Another one of our properties of gases that's important for you to know is about viscosity. So viscosity is all about the ability of a gas to flow or not flow. And gases flow really, really easily. This is in the Macy Parade. If you check out Spider-Man there, he's my favorite superhero, in case you didn't know. And essentially this Spidey guy had one little teeny tiny hole. But with gases, that's all it takes. Because small holes allow for something that is easily able to flow, high viscosity, to come out with no problem. And our next property is density. Guys, when you think about what a gas is in general, of course the molecules are far apart. That's how density works. Therefore, it is low density, right? Okay, keep going. Number 5. If you were to, just like in the picture showing, take a container where the gases are separated, green and purple, and then end up opening that stopcock, now all of a sudden we end up with a situation where the gases easily mix. This is normal. That's why if I were to light a match in one side of the room, then you would smell it pretty quick on the other side of the room. Okay? And number 6 is gases take on the shape, and this is a big one. Take note of it. They take on the volume of the container. So if I tell you that I take a gas and I put it in a 2-liter container. Whoop, where's my pen doing? There we go. 2-liter container. Then think of what that means. If the container is 2 liters from a size perspective, that is also the volume of the gas. All right, folks, that's the beginning. Let's finish up here. Couple implications of how these things work together. So, important stuff. A volume of a gas will go down when pressure goes up. And you can see that this is the relationship from a formula perspective that we end up with. Now, you're not going to use that formula exactly, but something similar. Things that you need to make note of, though, is just recognize as pressure increases, volume decreases. And the opposite holds true. As pressure decreases, volume will increase. That's what we mean by an inverse relationship. Now, what you see in your formula sheet where it has this P1 and V1, that's all about saying that it's the starting, so the initial, what you begin with pressure. and vice versa. We've got, of course, an initial. How do I erase that? Oh, no. There we go. And an initial volume. Okay? Same dealio to the other side. If P2, that is a final pressure, and vice versa. Well, I'll try to get my writing better here. Sorry, guys. Uh-oh. There we go. V2 is our final volume. Wow. Sorry if I'm making you seasick. I'll get used to this. That's supposed to say volume. Final volume. Okay, well, let's move on. Here's another relationship. Gases expand. In other words, volume goes up as the temperature goes up. So we say again, this is not an inverse relationship. This is a direct relationship. Consider what this means. This means that if volume goes up, then temperature goes up. This also means that if volume goes down, the temperature will go down. Okay? We have, once again, a way to show that. So basically, guys, the graphs are one of the ways that you could see that if you actually did this lab and figured out the information and saw what happened to a gas as you increase the temperature, the volume goes up, graph it, that formula that you see here is derived from the graph, which is kind of cool. Notice similar type things. The ones mean initial, right? Versus the twos mean final. You need to pay close attention to those ones and twos. So 1 equals initial versus 2 equals final. This is going to mean a whole lot once we get into a little bit later this week. Okay, so pay attention to them. The last one, number 3. Let's throw pressure back in there. In this situation, as temperature goes up, then the pressure is also going to go up. Now, notice, guys, for each of these, if it's pressure and temperature that are changing, then the other variables staying exactly the same. So pressure and temperature change, which means volume is constant. This is the same thing over here. If volume and temperature change, then what remains constant? It's pressure. Okay, go back to this one. If pressure and volume are the ones that are changing, then that means, ding, 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 temperature is constant, right? Again, be aware, take note, it'll come back. All right, folks, for this last one, no difference. Take note, initial pressure and temperature versus final temperature and pressure. And we have a similar relationship here as what was shown on the previous graph. That, please make note, when pressure increases, temperature also increases. And that means the opposite is true. When pressure decreases, temperature will also decrease. All right, folks, that's it for this podcast. I will talk to you again soon. Take care, all of you.